organic chemistry, that is your hydrocarbons. Okay, so we have completed the organic chemistry, introduction to organic chemistry. That is the foundation of all the chapters we are covering so far. Okay, so the hydrocarbons chapter. What is hydrocarbon? So an organic compound which is made up of hydrogen and carbon. It is called a hydrocarbon. For example, if I write C2H6, is it a hydrocarbon? Yes, it is a hydrocarbon because it is composed of carbon and hydrogens. But if I say C3H8O, is it a hydrocarbon? No, it is not a hydrocarbon because here oxygen atom is added. Okay, hydrocarbons are organic compounds in which only hydrogen and carbon are present. No other element should be there. If I write C6H5Br, is it a hydrocarbon? No, it is not a hydrocarbon because bromine is present here. Okay, so hydrocarbon is the organic compound which contains only the carbon and hydrogen. C6H6, CH4, C2H6, C2H2, all these are my hydrocarbons. Okay, so this we already discussed in the organic chemistry chapter, how to display the organic molecules. So how to display the hydrocarbon? First is your displayed formula, second is your structural formula, and third is your skeletal formula. In displayed formula, you show all the bonds of carbon, carbon and carbon hydrogen. So it is pentane. That means there should be 5 carbon atoms and then you have to satisfy the valency of carbon with hydrogens. Structural formula of pentane, that means you do not have to represent the bonds, you just have to write down the name of the atoms. So CH3, CH2, CH2, CH2 and CH3. So this is my structural formula of pentane. Skeletal formula, in skeletal formula you do not show the CH bonds, you have to show only CC bonds. Okay, so 1, 2, 3, 4 and 5. So these are my displayed formula, structural formula and the skeletal formula of pentane. Is it clear?
Yes.
Okay. So here you have to note that all the carbon-carbon bonds are single covalent bonds, right? They are single covalent bonds. So the carbon atoms all display sp3 hybridization. Okay, they display sp3 hybridization. If they have 4 bonds, carbon is having 4 bonds, then it shows sp3 hybridization. 1 from S and 3 from P. So total becomes 4. So if they have 4 bonds, then it shows your 4 sigma bonds, then it shows sp3 hybridization. It means that alkanes have the maximum number of hydrogen atoms in their molecules and they are known as saturated hydrocarbons. So what are alkanes? Alkanes are organic compounds which have the maximum number of hydrogen atoms. For example, if I write this ethane, then the formula for ethane is this C2H6. This is the displayed formula of ethane. Okay, so this is what? This is alkane. We can see that I am having how many hydrogen atoms? 6 hydrogen atoms. But if I write alkene, then in case of alkene, you have only 4 hydrogen atoms. In case of alkyne, you have only 2 hydrogen atoms. So how do you define the alkanes? That alkanes are organic compounds which have the maximum number of hydrogen atoms in their molecules and are known as saturated hydrocarbons. You can remember saturated, like the first letter is S, S for single bonds. So whenever there is a single bond, it is a saturated hydrocarbon. Okay, all these 3 are hydrocarbons, alkane, alkene and alkyne, because they are composed of carbon and hydrogen. Clear? Write it down, the definition for alkanes. Okay. So this is the 3D displayed formula of pentane. In 3D displayed formula, we represent it like this. The dashed bonds, the wedge bonds are the bonds which are above the plane of paper, and the dashed bonds, these bonds, they are below the plane of paper. So this is the your 3D displayed formula. Okay, so you can write this like this: 1, 2, 3, 4, 1, 2, 3, 4, 5. Now hydrogen atoms you can represent like this. This hydrogen is above the plane and this hydrogen is below the plane. Similarly, this hydrogen is above the plane and this hydrogen is below the plane. So the 3D displayed formula, it shows the tetrahedral arrangement. Tetrahedral means it is connected to 4 bonds. This carbon atom, it is connected to 4 bonds around each carbon atom. And the approximate bond angle is 109.5 degrees. That means in sp3, the bond angle is, in sp3 hybridization, the bond angle is 109.5 degrees. So methane CH4, It is a tetrahedral arrangement because all the hydrogens are connected like this. One hydrogen is above the plane and one hydrogen is below the plane. So it is a tetrahedral arrangement. It is attached to 4 hydrogen atoms. Okay. So what is the bond angle of methane? So bond angle of methane is 109.5 degrees. In this point, this is your above the plane for hydrogen and this is your below the plane for hydrogen. This hydrogen is in the plane. So this is your homework question. Homework questions. That first question is that icosane is a straight chain alkane whose molecules contain 20 carbon atoms. What is the molecular formula of icosane? Draw the skeletal formula of icosane. So there are 20 carbon atoms. You have to satisfy the valency of carbon with hydrogen. Draw the discrete formula and the skeletal formula for cyclopentane. What is the general formula of cycloalkanes? And give 2 references between a molecule of cyclopentane and a molecule of pentane. Now we'll read about the reactions of alkanes. Okay, so first of all, alkanes are unreactive. They are unreactive compounds. How we can explain this unreactivity? Because of the small difference in electronegativity between carbon and hydrogen. Okay, carbon is also 2 point something and hydrogen is also 2 point something in the Pauling scale. We have read it in chemical bonding also. So there is a very small difference in electronegativity between carbon and hydrogen. So it is not polar. So their atoms share the pair of electrons in the single covalent bond almost equally. That's why they form which type of bond? Covalent bond. Therefore, alkane molecules, they are not polar. That means they are non-polar. So if they are not polar, so they are not attacked by nucleophiles or electrophiles. What are nucleophiles? Nucleophiles are your negatively charged attacking reagents. Electrophiles are your positively charged attacking reagents. They may be neutral also. We have read the examples also. Okay, so nucleophiles are electron rich and electrophiles are electron deficient. So if they are not polar, so they are not attacked by nucleophiles or electrophiles. They have no partial positive charge, because if they have partial positive charge, then who will it attack? Nucleophile will attack. If they have partial negative charge, then who will attack? Electrophile will attack, right? Because electrophile is electron deficient. So obviously it will attack the electron rich compound. Nucleophile is electron rich, so it will attack the electron deficient, that is partial positive compound. So if they are not polar, so they are not attacked by nucleophiles or electrophiles. No partial charges are developed there. Neither do they have areas of high electron density to attract electrophiles. But still they do some reactions, which I'll tell you in the next slides. But if anyone asks you the reactivity of alkanes, so you have to say they are generally unreactive, but yes, they exhibit reactions under certain conditions. They exhibit substitution reactions. Okay. Alkanes do react with oxygen. In combustion reaction, we have studied that alkanes, when they react with oxygen, they form carbon dioxide and water. This is a combustion reaction, and also undergo substitution by halogens in sunlight. Okay, methane, when chlorine is an attacking reagent in the presence of sunlight, then HCl is removed from here, and we have CH3Cl plus HCl. Then again this step occurs. CH3Cl again reacts with chlorine. Then what happens again in the presence of sunlight? Again the removal of hydrogen, it becomes CH2Cl2 plus HCl. Okay. Similarly, CH2Cl2, it again reacts with chlorine in the presence of sunlight, and we have CHCl3 plus HCl. And the last reaction, you have to write it on your own. We get CCl4 when all the hydrogens are removed. So the alkanes only show 2 types of reaction. One reaction is combustion, and the second reaction is the substitution by chlorine. And why they are unreactive? So the reason is here. Is it clear why they are unreactive and what are the reactions they exhibit?
Yes.
Write it down.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Okay, so alkanes show only 2 types of reactions. One is your combustion and the second is the substitution by chlorine.
And
Okay. Okay, so first reaction is combustion of alkanes. Alkanes are often used as fuels. Okay, alkanes are often used as fuels. We burn them for many reasons: to generate electricity in power stations, to heat our homes and cook our food, to provide energy needed in industrial processes, and to provide fuel for ships, aeroplanes, trains, lorries, buses, cars, and motorbikes. So we have studied the fractional distillation of petroleum. Okay, in the fractional distillation of petroleum, we have different fractions where we have petrol, we have gasoline, we have diesel. Okay, so the uses of these are written here. They all are alkanes. We have bitumen. They are all are fractions in the fractional distillation of petroleum. So the alkanes, what is the most common use of alkanes? They are used as fuels. So if you burn an alkane in the plenty of oxygen, the alkane will undergo complete combustion. So when we burn an alkane in plenty of, that means excess of oxygen, we have a complete combustion. But similarly, if I burn the alkane in the limited supply of oxygen, then alkane will undergo incomplete combustion. Incomplete combustion. All the carbon will be oxidized fully to form carbon dioxide, and all hydrogen it will be oxidized to form water. Okay, so the product is carbon dioxide and water in case of complete combustion. But in case of incomplete combustion, the products are carbon monoxide and water, which is very poisonous. Monoxide is very poisonous. So octane is one of the alkanes in petrol that is burned inside the internal combustion engine in the motor vehicles. Some of the octane will undergo complete combustion in a car engine. Octane means there are 8 carbon atoms. H18 is, what is the general formula for alkanes? General formula for alkanes is CnH2n plus 2. Okay, so if N is my 8 carbon atom, then you can easily calculate the number of hydrogen atoms. 2 into 8 plus 2, that is equal to 18. So this is the formula for octane. When we do the complete combustion of octane to produce carbon dioxide and water, these 25, 16, 18 are just to balance the equation. So the equation can also be written as, if you have to take the 1 mole of C8H18 octane, then you have to divide the equation by 2. So it is like this: 12 half and 8 CO2 and 9 H2O. So in complete combustion, we get carbon dioxide and water. In incomplete combustion, we get carbon monoxide and water. The general formula for writing an alkane is CnH2n plus 2. Okay, and octane is the alkane which is present in petrol, which is burned inside the internal combustion engine in motor vehicles. This is just an example to show the reaction. Next is that the pollution which is caused from burning the hydrocarbon fuel. So when there is incomplete combustion, carbon monoxide is produced, which is a very polluting gas. So when it occurs when there is a limited supply of oxygen. So when the petrol or diesel is mixed with air inside a car engine, there is only a limited supply of oxygen. Under these conditions, not all the hydrocarbon in the hydrocarbon is fully oxidized to carbon dioxide. Some is partially oxidized to carbon monoxide gas. This process is called incomplete combustion. This is octane when it reacts with oxygen in incomplete combustion. That means in the limited supply of oxygen, we have carbon monoxide and water. And this is the word equation: octane plus oxygen. In incomplete combustion, we have carbon monoxide and water. Okay. So carbon monoxide, why it is harmful, why it is a poisonous gas, because it binds with hemoglobin in your blood, and the hemoglobin, they can no longer bond to oxygen, and so it cannot transfer oxygen around your body. Victims of carbon monoxide poisoning, it will feel dizzy, then lose consciousness. If not removed from the toxic gas, the victim will die. So you can see how poisonous, how harmful this gas is. It is odorless, so this adds to the danger. This is why faulty gas heaters in which incomplete combustion occurs, they can kill unsuspecting people in rooms with poor ventilation because of this carbon monoxide gas. because of the incomplete combustion produced, and from this carbon monoxide is liberated, which is very harmful. How it is harmful? So some biology is applied here. It binds with hemoglobin in your blood, and it can no longer bond with oxygen, so it cannot transport oxygen all around your body. So as well as releasing carbon monoxide, road traffic also releases acidic nitrogen oxides, mainly NO and NO2. These contribute to the problem of acid rain. We have read this in the chapter nitrogen and sulfur. So acid rain, it can kill trees, aquatic animals. So acid rain also erodes limestone buildings and statues, as well as corroding metals such as iron. So this is about the harmful effects of these gases, carbon monoxide, NO and NO2. Discussed this thing that in complete combustion your carbon dioxide and water are produced from alkanes, and in incomplete combustion your polluting carbon monoxide gas is produced. So you can take a screenshot of this slide. So this is the pollution from burning hydrocarbon fuels, that the carbon monoxide gas is released. Another pollution is this. Okay, another pollution we'll study in next slide. This is carbon monoxide, how it is poisonous biologically. So it binds with hemoglobin in the blood and can no longer bond to oxygen. It cannot transport oxygen around your body, and then if it is not removed, the victims will die. Another pollution caused by these gases are this NO and NO2, which are released from road traffic. They contribute to the problem of acid rain. So here the image you can see that all the trees, they have been damaged by acid rain. So in normal combustion, nitrogen gas in the air, it is not oxidized in normal combustion, but in the very high temperature in car engines, oxidation occurs. Oxidation of nitrogen occurs, and a variety of nitrogen oxides can be formed and released in the car's exhaust fumes. For example, nitrogen reacts with oxygen to form nitrogen monoxide, which further combines with oxygen to form nitrogen dioxide. Here, this image is also showing that the vast number of cars on the roads, it pollutes our atmosphere. Nitrogen oxide gases are released from traffic, and it contributes to photochemical smoke as well as acid rain.